Hey, this is Presh Talwalkar reminding you to mind your decisions. You are waiting for your flight to Seattle, and to pass the time, you call 3 friends in Seattle. You independently ask each one if it is raining. All 3 of your friends say, yes, it is raining. But each friend lies with probability 1/3 and tells the truth with probability 2/3. Can you solve for the probability it is actually raining in Seattle? This is adapted from an interview question that was asked at Facebook. Pause the video if you'd like to give it a try, and when you're ready, keep watching to learn how to answer this interview question. So we can get started by drawing a probability tree. One branch will be if it actually is raining in Seattle. Now, if all 3 friends are telling the truth, they will all say yes. This happens with a probability of 2/3 for each friend, and since they're independent, we can multiply the probabilities to get 8/27. The other branch will be if it's not raining in Seattle. Now, if all 3 friends are lying, then they will also all say yes. Each friend lies with a probability of 1/3, so we end up with the probability of 1/27 that all 3 are lying. We now want to calculate the probability of each branch. But there's a problem. We need to know the probability that it rains in Seattle. This information was intentionally omitted from the interview question. Unlike a textbook problem where all the information is given to you, the interviewer wants to know, can you do more than solve textbook problems? I'll mention that many people thank me for covering such problems, saying Mind Your Decisions videos have helped them get high-paying tech and finance jobs. So what you're supposed to do at this point is ask the interviewer for the probability. The interviewer might tell you that it's 25%, or they might tell you to solve for the general case that the probability of rain is equal to P. So let's solve for the general case. We'll write the probability of rain is equal to P, so the probability that it does not rain is 1 minus P. We can now calculate the probability of each branch by multiplying the respective probabilities. The top branch will be 8P all over 27, and the bottom branch will be 1 minus P all over 27. The top branch is equal to the probability that all 3 people say yes given that it's raining, and the bottom branch is the probability that all 3 people say yes given that it's not raining. To solve for the chance that it actually is raining, we want the probability of the top branch divided by the sum of these 2 probabilities. But in an interview, you might want to illustrate that you know something called Bayes' rule. So we want the probability that it actually is raining given that all 3 people say yes. So we apply the Bayes' rule formula and we end up with the following fraction. So this is the probability of the top branch divided by the sum of the 2 probabilities. We substitute what we've calculated, and then we need to simplify this. Notice the 27s will cancel out, and then we simplify the denominator, and we end up with 8P all over 7P plus 1. And that's the answer. I think this is a wonderful interview question. Many applicants will have the technical skills to solve a probability problem like this. But how many will have the courage to ask for missing information? Thanks for watching and for making Mind Your Decisions one of the best channels on YouTube. Thanks for watching and thanks for your support.